Welcome to this lecture on CSS basics and styling fundamentals. Today, we're going to walk through some foundational concepts in CSS, how it differs from HTML in terms of structure, how to write CSS rules directly, and how to apply interactive effects like hover styles using class-based selectors. Let's get started. One of the first things to understand is the structural difference between an HTML file and a CSS file. In HTML, you can type an exclamation mark and hit Tab or Enter to generate what's called a boilerplate, that full starter template with a doc type declaration, HTML tags, head, and body. CSS does not have any boilerplate like that. When you open a CSS file, you simply start writing your style rules directly. There's no setup required. So to be very clear, the exclamation mark shortcut is an HTML-only concept. It's a quick way to scaffold your HTML document structure. In CSS, that concept simply doesn't exist. You open the file and immediately begin writing your tag selectors and style declarations. Keep this distinction in mind, as it's a common point of confusion for beginners. So how do you actually write CSS? The syntax is straightforward. You start with a selector, for example, H1 to target all heading 1 elements. Then you open a pair of curly braces, and inside those braces, you write your style declarations. Each declaration is a property value pair, like color red or font size 32 pixels, followed by a semicolon. That's the complete structure of a CSS rule. Let's break down the anatomy of this rule. The selector tells the browser which HTML element to apply the style to. The property is what aspect of that element you want to change, its color, size, spacing, and so on. The value is the specific setting for that property. Together, the property and value inside the curly braces form what's called the declaration block. Every CSS rule you write will follow this exact pattern. There are two common places where CSS can live. First, you can write CSS inside a style tag within your HTML file's head section. This is called internal CSS. Second, and more commonly in projects, you create a separate .css file and write your styles there directly. Either way, the CSS syntax itself is identical. You're just choosing where to put it. In a separate CSS file, you don't need any HTML tags around your styles at all. The key takeaway here is that in an external CSS file, you write styles directly. No style tag, no HTML structure around it, just the CSS rules themselves. This is the approach used in real-world projects because it keeps your HTML and your styling logic cleanly separated, making both files easier to read and maintain. Now let's talk about hover effects. A hover effect is a style that activates when the user moves their mouse cursor over an element. This is extremely common for navigation links. You want some visual feedback so the user knows the link is clickable. The way to write this in CSS is by using the :hover pseudoclass. You write your selector, then add a colon followed by the word hover, and inside the curly braces you define what changes when the mouse is over that element. The :hover portion is called a pseudoclass. It's not a real class you add to your HTML. It's a built-in CSS keyword that represents a specific state of an element, in this case, the hover state. So the rule only applies when the user's cursor is hovering over the matched element. The moment the cursor moves away, the style reverts back to normal. Here's where CSS really shows its power. Imagine you have a navigation bar with 5 or 6 links, and you want all of them to change color on hover. You could technically apply a style to each one individually in your HTML, but that becomes tedious and hard to maintain very quickly. The smarter approach is to use a CSS class. By targeting all anchor tags inside a class like navItem, a single CSS rule applies the hover effect to every single link at once. This is one of the core reasons CSS exists as a separate language. Rather than repeating the same styling instruction over and over in your HTML, you write it once in your CSS and let the browser apply it everywhere the selector matches. If you ever want to change the hover color later, you change it in one place and it updates across your entire navigation automatically. That's the principle of keeping style and structure separated. Let's look at the full picture of how this works with a class-based selector. In your HTML, you assign a class, say navItem, to each list item in your navigation. Then in your CSS, you write a rule that targets anchor tags inside any element with that class. First, you define the default style for the link. Then, using the same selector plus :hover, you define what it looks like when hovered. The browser handles the switching automatically. Notice the pattern here. You have a default state rule that sets the baseline appearance of the links, and a hover state rule that overrides specific properties when the cursor is on the element. You don't need to rewrite the full style in the hover rule, only the properties you want to change. Everything else from the default rule stays the same. This layered approach is fundamental to how CSS cascade and specificity work. Something worth highlighting from this session is the collaborative approach to learning. Students who have already completed exercises are encouraged to help those who are still working through the concepts. Asking questions, whether to an instructor or a peer, is a core part of the learning process. If something is confusing, the right move is to speak up, not to stay stuck silently. The instructor in this session made a point that students who finish ahead of schedule should use that time to support classmates who need help. This kind of peer learning reinforces your own understanding. Teaching something is one of the best ways to solidify what you know. And for those who are still building confidence, having a fellow student explain a concept in a different way can sometimes make it click much faster than hearing it from an instructor alone. Picking up right where we left off, let's now look at how to structure an About page in HTML. Just like any other page section, the About page content lives inside the main tag. This is consistent with how we build all our page sections. The main tag acts as the primary container for all meaningful content on the page. So when you're building out your About page, you don't create some entirely separate structure. It still sits inside that main tag, just like the hero section did. This keeps your HTML semantically consistent and well organized across the entire site. Before moving into the About section, it's important to properly close off the hero section. When you click the closing tag in your editor, the section collapses. This is a visual confirmation that your hero section is complete and properly wrapped. Keeping sections cleanly opened and closed prevents nesting errors down the line. Think of it like bookends. Your opening section tag and your closing section tag define exactly where the hero section begins and ends. Everything in between belongs to that section. This visual boundary in your editor helps you stay organized as the page grows longer and more complex. One really useful habit when writing HTML is to add comments to label your sections. Comments are not rendered in the browser. They're purely for the developer reading the code. You can mark where a section starts and where it ends, making it much easier to navigate your file as it grows. The keyboard shortcut to quickly add or remove a comment in most code editors is Ctrl plus the / key. This is a shortcut worth memorizing. It lets you comment out a line or uncomment it instantly without typing the comment syntax manually every time. These shortcuts are noted down for reference. When you need to apply this same style, say a color, to multiple elements, writing it inline on each one gets tedious fast. Imagine changing that color later and having to update it in 10 different places. This is exactly why we use CSS. It lets you define a style once and apply it everywhere it's needed. This is a core principle in programming called dry, don't repeat yourself. Instead of duplicating the same color value across every element, you write it once in your CSS. If you ever need to change it, you update one line and everything reflects that change instantly. CSS makes your code maintainable. To demonstrate CSS in action, let's look at changing a color. Instead of adding a color attribute inline in HTML, you write a CSS rule that targets the element and sets the color property. Here, setting color to red immediately updates how that element appears in the browser. It's a simple but powerful demonstration of how CSS controls visual presentation. Notice how the CSS rule connects directly to what you see rendered in the browser. The property name is color, the value is red, and the result is exactly what you'd expect, red text. This direct relationship between your CSS declaration and the visual output is the foundation of how all styling works on the web. A common question that comes up is whether you can use the HTML tag instead of CSS grid to create grid-like layouts. Technically, yes, it works, but the table tag was designed for displaying tabular data, like spreadsheets or datasets, not for general page layout. Using it for layout is considered outdated practice. The recommendation is clear. Avoid using table tags for layout purposes. While you might see it done in older websites or legacy codebases, modern web development uses CSS Grid or Flexbox for layout. Table tags should be reserved for actual tabular content, like a schedule, a pricing comparison, or a data report. Mixing structure and presentation this way leads to harder-to-maintain code. Now, let's talk about commenting your code, something that might seem small but makes a huge difference as your projects grow. In HTML, you can wrap any section of code in a comment block, and it won't be rendered by the browser. It's purely for you, the developer, to stay organized. The quickest way to add or remove a comment is using the shortcut Ctrl and the / key. This is mentioned in the notes as well, and it's worth trying out all the shortcuts available to you because they genuinely speed up your workflow. The real power of commenting is in marking sections. You place a comment at the start of a section and another at the end, labeling what that block does, like row section starts here and row section ends here. This makes it very easy to track where each part of your layout begins and ends. When you label your sections with comments like this, tracking your code becomes much easier. You can immediately see where one section ends and another begins. Once a section is clearly marked with a comment, you know exactly where to start writing new code for that section. No more scrolling through hundreds of lines guessing where things are. Moving on to heading tags. In HTML, we have H1 through H6 for titles and headings. While all of them work, the important principle is to give priority to one main heading, typically H1, for the hero section of your page. Think of H1 as your page's primary headline. The H1 is reserved for the most important heading, usually in the hero section. For everything else, you work your way down. H2 for major subheadings, H3 for smaller ones, and so on. The idea is to scale up or down depending on the visual and semantic importance of each title on the page. When it comes to actually writing your titles and paragraph content, you have two options: write them yourself or use an AI tool to help generate them. Both are completely valid. For learning purposes, the instructor uses existing content from the project rather than generating new text. The focus is on structure, not copywriting. For this exercise, we're keeping it focused, just a title and a paragraph. The H1 holds the main heading, and the paragraph tag wraps the supporting description text. The instructor places the title inside an H1 tag and copies the paragraph text into a P tag. The paragraph text appeared slightly small visually, so adjustments might be needed, but the structure is correct. Notice how both the title and paragraph live inside the same container div. This grouping is intentional. It keeps related content together, which makes styling with CSS much cleaner later. The H1 and P tags are the two most fundamental content tags you'll use on almost every section of a web page. Images are placed using the im tag with a source attribute pointing to the file. In this case, the instructor is using a PNG file called herroad.png. One thing to note, the original image had a background, so the background needed to be removed first before it could be cleanly placed into the layout. Using PNG format is important here because PNGs support transparent backgrounds. Once the background is removed from the image, it sits cleanly over whatever background color or design is behind it in the layout. Different sections can use different images. Each section can have its own unique visual. There is an important question that comes up often. Can you use the table tag instead of grid or flexbox for laying out content? The short answer is no, not for layout. The table tag exists specifically for displaying structured data. Think rows and columns of information, like a comparison chart or a data report. For things like navigation menus, image grids, or page sections, the instructor strongly advises against using the table tag. It creates accessibility issues and makes responsive design much harder. Those use cases are better handled with CSS Grid or Flexbox, tools that are built exactly for layout. Table tags are for data, not design. Another question that comes up is whether you can round the corners of a div element. And yes, absolutely. This is done with the CSS property border radius. You give it a value in pixels or a percentage, and it curves the corners of the element. It's one of the most commonly used styling tricks for cards, buttons, and image containers. The higher the border radius value, the more curved the corners become. At 50%, a perfectly square element becomes a circle, which is great for profile pictures or icon containers. This property gives you a lot of creative control over the shape of your elements without needing any complex techniques. Continuing from where we left off, let's talk about how images are handled inside an HTML layout. When you place an image in your HTML, you might notice it can sometimes appear too large or too small, depending on where it sits relative to other elements, like paragraphs. Getting the sizing right is an important part of building clean layouts. In this case, an image was placed alongside a paragraph, but the image appeared a bit too small. This is a common issue when you drop an image into a layout without explicitly controlling its dimensions or the surrounding container's behavior. One important technique discussed here is the use of PNG images where the background has been removed. Instead of using an image that has a solid white or colored background, a background removal tool was used to strip the background out, leaving only the subject of the image. This makes the image look much more natural when placed on top of any web page background. Using a background removal tool before placing images in your HTML is a professional practice. It ensures the image integrates cleanly into the design without an awkward white box around it, especially when your web page has a colored or gradient background. Another important practice when working with images in HTML is always providing alternate text, the alt attribute on your image tag. Alternate text serves two purposes. It describes the image to screen readers for accessibility, and it displays as fallback text if the image fails to load. This is not optional. It's a best practice every developer should follow. Now, let's look at layout structure. When you have two content blocks inside a parent div, say an image on one side and a paragraph on the other, by default, HTML stacks them vertically, one on top of the other. This is the normal block-level behavior. But what we actually want is for them to sit side by side on the same line. The fix is straightforward. You add display flex to the parent div. As soon as you do that, all the child elements inside that parent automatically line up horizontally on the same row. This is one of the most powerful and commonly used features of CSS Flexbox, and it solves the stacking problem instantly. Once you apply Flexbox, the elements line up, but that doesn't automatically mean they share equal space. If one div has more content than the other, it will naturally take up more horizontal space, while the smaller one takes less. The total width is divided unevenly based on content size. To fix this unequal distribution, you apply Flex 1 to each child element. This tells the browser to give each child an equal share of the available space inside the Flex container, regardless of how much content they hold. It's a clean and simple way to create balanced, equal-width columns. An important concept covered here is knowing when to actually use the HTML table tag. Tables are meant for one specific purpose, displaying structured, tabular data. Think of things like a list of student scores, a price comparison chart, or a schedule. If your data fits neatly into rows and columns and represents a dataset, that's when the table tag is appropriate. What you should not do is use the table tag for building page layouts or navigation menus. That was a common practice in the early days of web development, but it's considered bad practice today. For layouts, use divs with Flexbox or CSS Grid. Tables are strictly for data, not structure. Rather than building every element from scratch, a better approach for things like menus and complex UI elements is to use pre-built components. Component libraries provide ready-made, styled building blocks that you can simply drop into your project. This saves significant development time and ensures consistent design across your interface. A student asked a great question here. Can you make a div's corners rounded? The answer is yes, absolutely. CSS provides the border radius property to round the corners of any element. This is called outward rounding. The corners curve outward, giving the element a pill or card-like appearance. This is extremely common in modern UI design. You simply add border radius with a pixel or percentage value to the element CSS. The larger the value, the more pronounced the rounding. A value of 50% on a square element will even turn it into a perfect circle. This is one of the most used CSS properties for modern card-based and button designs. The student then asked a follow-up. What if you want inward rounded corners? That is, instead of the corners curving outward, they curve inward, creating a concave shape. This is a completely different visual effect, and it turns out this is not achievable with a simple border radius property. As the instructor confirmed, inward rounded corners are a separate topic entirely. Standard border radius only produces outward curves. Achieving inward or concave corners requires more advanced CSS techniques, such as using clip path, SVG masks, or creative use of pseudo-elements. It's worth exploring separately when you need that specific effect. Continuing with Flexbox, once you apply display flex to a parent div, all child elements line up horizontally in a single row. Before that, they stack vertically by default. Now the instructor divides the total 100% width between two children. 25% goes to the image section, and 75% goes to the text content section. This split is based on the width of the parent div itself. To add breathing room between those two children, the instructor adds a gap property on the parent container, something like gap 10. This pushes the children apart without needing margins on individual elements. It's a clean, contained way to manage spacing inside a Flex container. The instructor also applies vertical padding, pi 10, directly on the section element. This adds consistent top and bottom spacing for the entire section. Using padding on the parent section is preferred over adding margin top to individual children, because if more content is added later, those children won't inherit the spacing automatically. This is a really important distinction the instructor makes. Flexbox is ideal when you need to arrange items in a straight line, either horizontally or vertically. But when you're dividing a layout into sections, like splitting a row into halves or thirds, Grid is the better tool. The instructor notes they'll cover Grid in a separate section. When the image and text content have different heights, the image can appear stuck to the top. By adding align items center to the flex parent container, the image gets vertically centered relative to the tallest child. The instructor emphasizes putting this on the parent div, not the image element itself, because it's a flex container property. The instructor demonstrates two ways to create a visual divider between the image and text sections. The first approach creates a separate div with a small width, a background color, and a set height, essentially a thin colored bar. The second approach uses border right on the image div directly. Both work, but the instructor prefers the separate div approach because it gives equal, consistent spacing on both sides of the divider. Here's why the separate div wins. When you use border right on the image, the border sits right at the edge of the image element. The gap between the border and the text content looks uneven compared to the gap on the image side. The standalone div, on the other hand, sits between both elements, and the spacing is naturally balanced on both sides. A student asks about breaking a line of text mid-sentence. The instructor explains the BR tag. It forces a line break inside an element without creating a new paragraph. It's specifically for when you have text inside a single tag and need part of it to drop to the next line, like after a name or a phrase. The instructor gives a clear warning here. Some developers stack 2 or 3 BR tags to create visual spacing between sections. Don't do that. The BR tag is only meant for breaking text within the same element. If you need spacing between separate content blocks, use a proper container with padding or margin instead. Now the instructor moves on to building a skills section. The design shows a centered heading and paragraph at the top, followed by a collection of skill cards arranged in a multi-row layout. The goal is 3 cards per row. This is a very common portfolio section pattern: a title, a brief description, and then a visual grid of skills. Using what's been covered so far, the instructor applies display flex to the parent div holding all the skill cards. To get exactly 3 per row, each card gets a width of roughly 33.33%, 1/3 of the total container width. A gap property adds spacing between the cards. This works, but the instructor hints that this approach isn't the most optimal. The instructor makes a key point. While you can use Flexbox with percentage widths to create a 3-column layout, it's not the best approach. Manually calculating 33.33% is awkward, and things can break when content changes. CSS Grid is designed exactly for this, dividing space into equal sections. The instructor says Grid will be covered in a dedicated section, but it's worth knowing when to reach for it. The instructor points out a practical spacing tip. Instead of adding margin top to individual child elements, it's better to use spacey on the parent. Here's why. If you later add more content inside that parent, the spacing automatically applies to the new children too. With margin top on individual elements, you'd have to manually add it to every new item you create. A student asks whether CSS can create an inward rounded corner, essentially a concave notch instead of the typical outward curve. The instructor looks it up and confirms. Standard CSS border radius only produces convex outward curves. There's no native CSS property for an inverted or inward radius. In Figma, there's actually a plugin that handles inverted radius as a separate component feature. But in pure CSS, achieving a concave corner requires creative workarounds, like using pseudo-elements, clip path, or SVG shapes. The instructor acknowledges this is a more advanced topic and keeps the focus on standard CSS for now, noting the Figma plugin approach is separate from what CSS natively supports. Continuing from what we covered with Flexbox, let's now move into the CSS grid system, which is the go-to layout tool whenever you need to divide your content into equal or defined sections. The instructor makes a clear distinction here. While Flexbox works, grid is simply better when you're splitting things into parts. Here's the key difference. With Flexbox, if you want 3 items per row, you have to wrap every group of 3 in its own parent container. That gets messy fast. With Grid, a single parent handles everything, no matter how many children you have. The grid automatically places them into rows and columns as you define. That's a huge advantage for divided layouts. So when you're building a layout that divides content into equal sections, like a project gallery or a skills grid, reach for Grid. It keeps your HTML clean and your CSS manageable. When you first apply display grid to a parent, the default behavior is 1 column per row. So every child element takes up an entire row by itself. They stack vertically. This is the baseline: 1 row, 1 column, 1 item. To change this, you need to define how many columns you want. The moment you define 2 columns using grid template columns, the grid places 2 items per row. Add a third item, and it wraps to the next row automatically. This is the fundamental power of grid. You define the column structure once, and the items fill in naturally. To define columns, you use the grid template columns property on the parent. If you write 3 values, you get 3 columns. The instructor shows that with 3 columns defined, items fill left to right, 1, 2, 3, and then automatically wrap to the next row. You can define as many as 12 columns in a standard grid system. Notice that the parent is the one defining the column structure. The children don't need to know anything about layout. They just exist, and the grid places them. Rows are created automatically as more children are added. This is what makes grid so clean. Just like Flexbox, Grid supports the gap property. You can add spacing between grid cells simply by writing gap 10 pixels on the parent. This adds consistent spacing both between columns and between rows. The instructor confirms this works the same way as in Flexbox, familiar and easy to apply. Grid also supports align items, which controls vertical alignment within each cell, just like in Flexbox. However, the instructor makes an important distinction. Justify content is a Flexbox-only property. In Grid, you don't get justify content. So align items works, but justify content does not. Keep that difference in mind. The instructor uses a great analogy here. Think of it like black and white paint. You can't apply both at the same time. Either you use display flex or display grid. They are values of the same display property, so they are mutually exclusive. Pick the one that fits your layout needs and stick with it for that container. Now, what if one item needs more space than others? That's where call span, or more precisely, grid column span n, comes in. The instructor uses a land analogy. Imagine a father with 3 plots of land. Each child normally gets 1 plot, but if the eldest son needs 2 plots, you assign grid column span 2 to that element. It takes 2 column slots, and the others take 1 each. You can even span all 3 columns, giving one item the full width of the row. The span value can go up to however many columns the parent has defined. This is how you create asymmetric layouts within a grid, mixing full width elements with smaller ones. Similarly, grid row span 2 allows an item to span across multiple rows vertically. The instructor demonstrates this with a box that takes up 2 row heights. Importantly, when you use row span, you also need to set height 100% on the element. Otherwise, it won't visually fill the taller space it's been assigned. This is a common gotcha. The grid reserves the space for the element, but the element itself won't stretch to fill it unless you explicitly set the height. Row span is used less frequently than call span, but it's essential for complex magazine style or dashboard layouts. The instructor introduces the concept of a 12-column grid, a standard in web design. The maximum number of columns you typically define is 12. Why 12? Because it's divisible by 1, 2, 3, 4, 6, and 12, giving you enormous flexibility. With call span 4 on each of 3 items, they fill the row perfectly. Change to call span 6, and you get 2 equal halves. The rule is simple. When the total span values in a row add up to 12, the row is full. Any additional item wraps to the next row. If they add up to more than 12, the overflow spills onto a new row. This system gives you precise, predictable control over your layout. The instructor applies all of this to build a real project section on a portfolio page. 3 columns, each containing a project card with an image. The images use width 100%, so they fill their grid cell, and object fit cover to prevent distortion. The image crops rather than squishes. This is the standard approach for image-heavy grid layouts. There's a choice between object fit cover and object fit contain. Cover crops the image to fill the space, great for consistent card sizes. Contain shows the whole image, but may leave empty space around it. For project galleries, cover is almost always the right choice. And don't forget the alt attribute on every image. It's required for accessibility. The instructor clarifies an important structural point. Sections always have width 100%. They span the full page width, which is necessary for full bleed background colors. But the content inside uses a container class with a defined max width, in this case 860 pixels, to keep the readable content centered and not stretched across the full screen. A common mistake is putting the container class directly on the section element. If you do that, the background color only stretches as wide as the container, not the full viewport. The section handles the full width background, and the container inside it constrains the content width. These are 2 separate responsibilities.
Once the grid cards are styled, the instructor wraps each card in an anchor tag so they become clickable links to the actual projects. Using target_blank ensures the link opens in a new browser tab, standard behavior for external project links. The key point is that wrapping in an anchor tag should not break the card's visual design.
Before moving on, here's a quick mental map of the grid properties covered. Display grid activates the grid. Grid template columns defines how many columns and their sizes. Gap adds spacing. Align items handles vertical alignment. And grid column span n plus grid row span n let individual children take up more space. These are the core tools you'll use in almost every grid layout.
With grid covered, the instructor introduces the next major CSS concept, the position property. Position is used when you need to place a specific element at a defined location on the page, independent of the normal document flow. This is how you create things like sticky navigation bars, floating buttons, or overlapping elements. We'll dig into this next. Now let's move into one of the most important layout concepts in CSS, positioning. Positioning allows you to precisely define where an element should appear on the page. Think of it like placing a label on top of a photograph. You're telling the browser exactly where that label should sit, relative to something else. There are 5 position values in CSS: static, relative, absolute, fixed, and sticky. Static is the default. Every element is static unless you say otherwise. It's not something you'd typically use intentionally. It's mainly used to cancel out another position value that was applied earlier. So we'll skip static for now and focus on the other 4. Static is essentially the do-nothing value. The only real use case is when some element already has a position, like relative, applied to it, and you need to remove that in a certain condition. You'd override it back to static. Otherwise, we start our journey from relative. Let's start with relative positioning. When you apply position relative to an element, you unlock 4 directional properties: top, bottom, left, and right. These move the element relative to its own original position. So if you say top 100 pixels, the element shifts 100 pixels downward from where it naturally sat. Here's the key thing to understand about relative. The original position of the element is still reserved in the layout. Even though the box visually moved, the space it used to occupy remains. You'll notice a gap where the element originally was. This can be a problem in real designs because that empty space can break your layout. One thing that trips people up is the direction of these properties. Top doesn't mean move upward, it means push away from the top. So top 100 pixels moves the element 100 pixels downward. Similarly, left 100 pixels moves it to the right. And you can't use top and bottom at the same time. That would mean place it at the top and the bottom simultaneously, which makes no sense. Now, absolute positioning works very differently. When you apply position absolute to an element, it is completely removed from the normal document flow. Its original position disappears. Other elements don't leave a gap for it anymore. The element floats free and is positioned relative to its nearest positioned ancestor. This is the fundamental difference between relative and absolute. With relative, the gap stays. Other elements don't move in. With absolute, the gap is gone. Other elements behave as if the absolutely positioned element never existed. This makes absolute much more useful for overlapping elements, like badges or labels on top of images. There's an important side effect of absolute positioning. The element loses its default block level full width. It shrinks to fit its content, almost like an inline element. So if you apply position absolute, and your element seems to disappear or look broken, you likely need to explicitly set a width on it. This is a very common gotcha for beginners. By default, an absolutely positioned element anchors itself to the body, the entire page. That means using top or left values to place it precisely inside a small card would require huge pixel values. But here's the trick. If the parent element has any position value applied, like relative, then the absolute child anchors to that parent instead. This is the key pattern in real-world design. This is the pattern you'll use constantly in real CSS work. The rule is simple. The element you want to use as the reference point, the parent, gets position relative. The element you want to move and place precisely, the child, gets position absolute. Now the child moves based on the parent's boundaries, not the entire page. Think of the parent with position relative as setting up a coordinate system. The top left corner of that parent becomes the 0, 0 point. Now, when you say top 4 pixels on the absolute child, it means 4 pixels from the top of the parent, not the top of the page. This makes placing elements inside cards, banners, and overlays very predictable. Here's a real design example. You have a course card, an image on top, course name below.
You want a badge saying starts in 3 days to appear on top of the image. You put the badge span inside the image's div, give the card or image container position relative, and give the badge span position absolute. Then you use top and left or right to fine-tune where it sits. If you had used position relative on the badge instead, you'd see that empty gap in the layout where the badge originally was, and the card's height would be thrown off. With absolute, the badge floats on top of the image with zero impact on the surrounding layout. That's exactly the behavior we want for overlay elements.
That covers relative and absolute positioning in depth. There are still 2 more position values to explore, fixed and sticky. Fixed keeps an element locked to the viewport no matter how much you scroll, which is perfect for navigation bars. Sticky is a hybrid that scrolls with the page until a threshold, then locks in place. Those will be covered in the next class.
So the instructor wraps up today's topic here and mentions that responsive design is what's coming up next. The plan is to finish off the current session's content, particularly around sticky and fixed positioning, and then move into responsive design in the next class. It's a natural progression from layout fundamentals into making those layouts actually work across different screen sizes. Specifically, the 2 positioning concepts that were introduced, sticky and fixed, are going to get a proper explanation in the next session. The instructor intentionally leaves them in the code without deleting the comments, so students can follow along when watching the recorded video later. That's a thoughtful move, keeping the code intact as a reference. The instructor gives a brief live preview of how position sticky works. As you scroll down the page, the header stays locked at the top of the viewport. This is a very commonly used pattern in real portfolio and commercial websites. Even though the full explanation is deferred to the next class, students can already see the visual behavior. The element sticks in place rather than scrolling away. The CSS behind it is actually quite simple. Just 2 lines, position sticky and top 0. But understanding when it sticks and what its parent container has to do with that behavior is what the next session will cover in detail. For now, just appreciate that this is achievable with pure CSS, no JavaScript needed. The instructor encourages students to keep building their portfolio as they learn. Rather than waiting until everything is taught, the idea is to continuously add designs and sections as new concepts are covered. The portfolio becomes a living project. Each new CSS or layout technique you learn gets applied directly to it. This is how real developers build, iteratively. For example, the instructor mentions box shadows on items, those visual depth effects on cards and sections. These get layered in as students learn them. The navigation bar with hover effects is another example. Each concept you cover in class should immediately find a home somewhere in your portfolio. That connection between theory and practice is what makes the learning stick. A student asks a great practical question. If you want to apply a hover effect to all navigation links at once, do you have to write separate CSS for each one, or can you do it in one go? This is a very common real-world scenario when styling an navbar. The answer is that you absolutely can target all links at once using a single selector, something like nav_a:_hover, and that rule will apply to every anchor tag inside the navigation. With Tailwind CSS, the approach is slightly different, since you apply utility classes directly in HTML, but the instructor notes this will be covered properly in the Tailwind sessions. Either way, you don't need to repeat yourself for every single link. The instructor lays out a clear roadmap for the coming days. Tomorrow is the final day of Tailwind CSS. Position sticky will be completed, and then responsive design will be introduced. After that, a 3-day break begins, during which Git and GitHub video content will be shared for students to study independently. After the break, JavaScript begins, and the instructor sets a target of covering the JavaScript basics by Friday. That's roughly 3 days of JavaScript. It's described as getting progressively more challenging from here on, so students are encouraged to keep up with the pace rather than letting material accumulate. And then there's Laravel, the backend PHP framework, waiting further down the line. The instructor acknowledges there's still a lot of ground to cover. This is a full-stack curriculum, and students are being taken through the complete journey from HTML and CSS all the way to a backend framework. That's a significant undertaking, and it's worth appreciating the scope of what's being built. A student asks about local installation of Tailwind CSS, how to set it up properly in a local development environment rather than using a CDN link. The instructor confirms this will be covered in the lab or terminal session. Local Tailwind installation involves using Node.js and NPM, initializing a config file, and setting up a build process. It's a bit more involved than just dropping in a CDN link. The local installation workflow is important because it gives you full control. You can customize your Tailwind configuration, purge unused styles for production, and integrate it properly with your project build tools.
The instructor plans to walk through this process, and it's a skill that will be essential once students move into real project development beyond just learning exercises. During the 3-day break, covering the 30th, 1st, and 2nd, the instructor will upload Git and GitHub video content for students to cover on their own. Git is the version control system, and GitHub is the platform for hosting and collaborating on code repositories. These are absolutely non-negotiable tools for any working developer. Students are expected to go through the uploaded videos and cover the Git and GitHub material by the 2nd. The instructor also mentions doing at least one live session on Git to walk through it together. Learning Git through video first and then reinforcing it in a live session is a solid approach. Version control is one of those topics that really clicks once you see it in action. A student asks a very honest and relatable question. Does the material actually stick as you keep learning, or do you keep forgetting things? The instructor gives a realistic answer. Yes, you will forget things. That's completely normal and expected. Forgetting is not a sign of failure. It's just how human memory works with new, complex information. The instructor's guidance is that it takes roughly 4 to 6 months of consistent practice before things start to feel safe and comfortable. The course itself is about 1.5 months, and then students need to put in roughly 3 more months of their own practice and project work. The recorded sessions are always there to revisit, so no one is ever truly stuck, but the key is to keep showing up and keep building. The instructor also highlights that senior students, those who have already gone through this material, are available to help during their free time. This is a valuable resource that newer students should take advantage of. Peer learning is incredibly effective because someone who just learned something recently often explains it in a way that's more relatable than a textbook. The instructor specifically mentions that some senior students have already built portfolio projects and have hands-on experience. Connecting with them through the workspace or group channel is encouraged. Learning in a community, asking questions, sharing code, reviewing each other's work dramatically accelerates progress compared to studying in isolation. So to wrap everything up, the course is at a pivotal point. The foundational CSS work is nearly complete. Responsive design and JavaScript are right around the corner. And the bigger picture, including Git, GitHub, and eventually Laravel, is all mapped out. The most important takeaway is this. Don't get discouraged by the pace or by forgetting things. Show up, keep coding, use your resources, recorded videos, senior students, and your instructor, and in 4 to 6 months, it will all start to feel natural. You've got this.